When we looked at univariate data, we were looking at what was happening with one variable. In this topic, we're going to be looking at bivariate data, bi meaning two. And so what we're going to be investigating is the relationship between two variables. Now, the two variables have got two different names. One will be the explanatory variable, and the other we will call the response variable. So before we start looking at any graphs for this particular work, what we need to be able to do is work out which variable is our explanatory and which one is our response variable. Previously, the explanatory variable was called the independent variable, and the response variable was called the dependent variable. This might actually help us in determining where we put each of our variables. So remember, explanatory was independent variable, response was the dependent variable. So the question that we ask ourselves is, what depends on what? Because if we can work out what is dependent, then we know that it goes on the y-axis, and the independent will go on the x-axis. Now, a couple of years ago, some of the boys in my class said the way that they remember it is from the band in excess. So in excess, independent on the x-axis. Now, it's really important that we get this right before we start doing our graphs. So in this example, we're asked to identify the response variable and to identify the explanatory variable. Remember, the response variable is the dependent variable and the explanatory is the independent. So what depends on what here? So in this first scenario, we're investigating the question, do older people sleep less? So our variables that we're dealing with are age and time spent sleeping. All right, so the question is, what depends on what? Does age depend on time spent sleeping, or does the time spent sleeping depend on the person's age? Hopefully, you're telling me the time spent sleeping depends on the person's age. So therefore, if it depends on the age, the time spent sleeping is dependent, and the age therefore would have to be independent. And of course, independent is the explanatory variable and the dependent is the response variable. In the next scenario, we're investigating the relationship between kilojoule consumption and weight loss. So the variables here are kilojoule consumption and weight loss. So again, we ask ourselves, what depends on what? Does kilojoule consumption depend on weight loss, or does the weight loss depend on kilojoule consumption? Hopefully, again, you can see that weight loss depends on kilojoule consumption. So if weight loss depends on the kilojoule consumption, it is the dependent, or it is the response variable, and therefore kilojoule consumption would be independent, or the explanatory variable. Last situation here, we are trying to predict people's height from their wrist circumference, and in fact this is something that actually does happen. So the two variables here are height and wrist circumference. Again, we ask, what depends on what? Does the height of someone depend on their wrist circumference, or does their wrist circumference depend on their height? Well, in actual fact, their height depends depends on their wrist circumference. So if the height depends, it is the dependent or the response variable, and therefore wrist circumference is the independent or the explanatory variable. For each of these scenarios now we've worked out the response variable and the explanatory variable. So why is that important? Well, now we know what is going to go on our x-axis and what will go on our y-axis. Remember, the explanatory variable goes on the x-axis. The response variable will go on the y-axis. And now we've got that information.